Hello everyone, welcome back to OTK Academy. Today we'll be looking at a integration question from the AQA 2018 paper 2. Now this question's worth 8 marks and it is a difficult question, so let's look into it. It says a function f has a domain R and the range y is greater than or equal to e. The graph of y equals fx is shown below. The gradient of the curve at the point xy is given by dy over dx being equal to x minus 1 multiplied by ex. And then it asks us to find an expression for f of x by fully justifying our answer. Now, if you look at the question again and try gather as much information as we can, first of all, we should be looking at the fact that they've mentioned the range of y being greater than or equal to e. And what that suggests is that the stationary point that you see, that minimum point, the y coordinate of that minimum point is e. We're not aware what the x coordinate is just yet. However, we will have to find that out later on in the question. So looking at the second piece of information, it tells us that the differentiated term, it gives us the differentiated term of the original equation. And in order to convert that back, so just if I write that down here on the side, dy over dx is equal to x minus 1 e to the x. Right, in order to get back to the original expression, we need to use integration by parts, and the reason being is that we have these sort of two different variables. So the general formula for integration by parts is the following. You have uv minus the integral of u dash v dx. Let's assign the value u to x minus 1. So u equals x minus 1. When we differentiate that, we just get 1. The reason being is that differentiating a constant gives us 0 and differentiating x is just simply 1. Now v dash is equal to e to the x, and integrating e to the x is just e to the x. Right, so if we sub that back into that format that we've written down, we get x minus 1 multiplied by e to the x minus the integral of 1 times e to the x, which is just e to the x. Now this is actually really easy to integrate. So we get y equals x minus 1 e to the x minus e to the x plus c. Now we're quite close towards the end. We need to figure out what this constant plus c is, and in order to do that, we need to make it the subject of the equation and know the value of y and x at any point on the graph. So in order to do that, we can look back at the graph and you'll notice that we've already got one of the y coordinates of this sort of stationary point, and we know at a stationary point dy over dx is equal to 0, or the gradient is equal to 0. So simply plugging that back into this sort of given equation will allow us to figure out the x coordinate of this stationary point. Just a second, let me just fix that. Right, okay, I'll just do this on the side here. So subbing in 0 equals x minus 1 e to the x. Right, now e to the x cannot equal 0 because it is not a real solution, and if you type the ln of if you type ln 0 on your calculator, you'll get a maths error. So the only real solution is x being equal to 1. Now subbing that back in to the equation, so those are our two stationary points, and if we just write that down here right now, 1 and e, right, and we just need to simply sub it back into the equation and rearrange for c. So we have e equals 1 minus 1 e to the x, which is just cancels out because multiplying by 0 gives us nothing. Right, now c equals 2e. And that's pretty much it. We've found the constant. Now we just need to write it back into the equation. Y equals e to x minus e to the x plus 2e. So those are the 8 marks. I hope you guys enjoyed that. Please like and subscribe, and we'll see you next time.